Okay, guys, it is Friday, and yesterday you guys looked at probability distributions, and today we are going to look at some probability rules, and just try to find the probability of some outcomes happening. So just four basic rules which you could find on your notes. One, that any probability is a number between 0 and 1. So the probability of event A would always have to be between 0 to 1. If it's 0, that means it never occurs. And if it's closest to 1, that means it is almost certain to occur. So, like when your coach says you should give 110%, you can't do that because you can only give 100%. You can't give anything more. So like you guys learned yesterday, with the dice example of the sums, if I were to add up all the probability of all the outcomes together, it will always equal 1. All the possible outcomes will always equal 1 when I add them all the probabilities together. All right, so the probability that an event does not occur is 1 minus the probability that it does occur. So that's considered to be something called the complement. There's lots of ways that you guys could see it. You guys could see it as not A or like A to the C power. And you're basically taking 1 minus the probability of event A happening. Okay, so the last one is that if two events have no outcomes in common, those are considered to be disjointed or mutually exclusive. So they have no outcomes that happen at exactly the same time. So if one event occurs in 40% of all trials and a different event occurs 25% of all trials, and the two never occur together at exactly the same time, then we would just be adding the probability of A plus the probability of B, or 40% plus 25% to get 65%. And we're going to focus more on this one right now, because once again, we were talking about mutually exclusive events, and these are events that cannot happen at the same time. Okay, so if we wanted to try to find the probability of mutually exclusive events, we would just add the probability of A plus the probability of B. So let's just look at an example. So if we have student athletes at a local high school may participate in one sport each season. During the fall, 28% of the students play basketball and 24% of the students swim. What is the probability that a randomly selected student athlete plays basketball or is on the swim team? So what is the probability that they swim or play basketball? Okay, so to figure out what this probability is, we would take the probability that they swim plus the probability that they play basketball. There is no overlap, and you guys will focus more on this on Monday when you guys look at Venn diagrams, but there is no overlap that happens between these two outcomes. So I can just take the 24% and add the 28% that played basketball, and you would find out that the probability that they either swim or play basketball is 52%. All right, so I have one that I'm going to ask you guys to do. It is actually this one. So I'm going to ask you guys to try this one. You guys are asked to find the probability of an athlete either playing basketball or on track. Okay. So now let's look at another scenario in which we have a bag that contains 3 blue chips, 6 black chips, 2 green chips, and 4 red chips. So overall, how many chips do I have in my bag? 3 plus 6 is 9, plus 2 is 11, plus 4, I have 15 chips. Okay, in my bag, I have 15 chips. All right, so this is asking me that what's the probability that I have a green chip or a red chip? Now, I don't have any possible way of having a chip that's both red and green. So what we're going to do is just take the probability that it's green plus the probability that it's red and just add those two outcomes together. All right, so what is the probability that it's green? Well, how many green chips do I have in my bag? I have 2 out of 15. are green chips. Now, what is the probability that it's red? Well, how many red chips do I have in my bag? It looks like I got 4 of them. So I got 4 over 15. So I'm just going to add those two outcomes together, and it looks like I get 6 over 15. 2 plus 4 is 6, and they have a common denominator, so it's 6 out of 15. Now, if I wanted to simplify it, which I do, I get 2/5. And that is the same thing as, I think it's 40%. There's a 40% chance that I could get a green or a red chip. Now, I'm going to ask you guys to look at this one. Okay, so we were looking at mutually exclusive events. That means they have nothing in common. Well, when they do have something in common, they are considered to be having overlapping events, that they have something in common. So what happens is when I have A and B happening at the same time, that means that I'm counting some of A and some of B. So let's just look at an example of a situation in which we might see this. Okay, so what is the probability of rolling either an even number or a multiple of 3 when rolling a standard number die? So that's just basically saying that we're looking at a 6-sided dice. Okay, all right, so let's look at one event, which is even. All right. So what is the possible outcomes that I have for an even die? Well, that's 2, that's 4, and that is 6. Okay. All right. So in that sense, I have a probability of having 3 out of 6 being even. All right. So let's look at a multiple of 3. So let's look at, well, is 1 a multiple of 3? No. Is 2 a multiple of 3? No. Is 3? Yes. Yes. 3 is a multiple of 3. 4 is not, 5 is not, 6 is not. Okay, so it looks like that probability is 2 out of 6. Now, do I have any outcomes that are both even and a multiple of 3? So what do I mean by that? Do I have any outcomes that are both in this set and in this set? Any outcomes that are being counted twice? And if I were to actually look at that, it looks like 6 is being counted twice. Okay, so that is 1 out of 6, happens to be even and a multiple of 3. So what we're going to do is we're going to take the to find the probability that it's even or a multiple of 3. We're going to take the probability that it's even plus the probability that it's a multiple of 3 minus the probability that it is both of them, even and a multiple of 3. Okay, so 3 out of 6 plus 2 out of 6 minus 1 out of 6. And if I actually look at that, it looks like it's going to be 4 out of 6 or 66%. Okay, all right, so let's look at another situation in which I'm rolling either an odd or a number less than 4. So let's look at odds. All right. All right. So that's going to be a 1, a 3, and a 5. A number less than 4. All right. So what numbers are less than 4? 1, 2, and 3. Okay. So we're trying to take the probability that it's odd or less than 4. Okay. So we're going to try to take the probability that it's odd. And it looks like that there's 3 possible options, which is 3/6, plus the probability that it's less than 4, which is 3 out of 6, minus they're both the probability that it's odd and less than 4. So how many times do I have a number that's odd and also less than 4? It looks like I got 2 outcomes. Okay, so 3/6 plus 3/6 minus 2/6, that looks like that is going to turn out to be 4/6, which is 2/3, which is 66%. Okay. All right, so let's just look at this one situation, and then I'm going to have you guys try a few, okay? All right, so I have a green or yellow card, or a card number 1. Okay, so I'm looking at all of my green. Ooh, that's a bad line. All of my yellow. Okay, so probability that it's green. Well, how many do I have overall? I have 40. There's a 10 out of 40 chance that it's green. The probability that it's yellow, well, once again, that's going to be 10 out of 40. Okay. Now, how about cards that are numbered 1? So it looks like I have 1, 2, 3, 4. So 4 out of 40. Okay. Now, is there any time in which all 3 of these things happen at one time? Okay. That it's green, it's yellow, and 1. And if I look at it, it looks like it happens twice. So we're going to subtract the intersection between them. And what I end up with is 22 out of 40, which is 55%. Okay. Now, I have a couple others for you guys. I'm going to ask you guys to try this one and this next one. And then I have one more Ed puzzle for you guys to try to do today. Thank you.